Yep, perfect. All right. So sorry about that, guys. Of course, come showtime, there's going to be some technical difficulties that we had here. But we looks like we've got them resolved now. Perfect. Just a little bit of a hiccup. Dwayne, are you ready to go? Perfect.
Yes, let's go.
All right. Excellent. Thank you so much for your patience, guys.
Okay, good morning, everyone. Welcome to this presentation. I hope it's both informative and enjoyable for you. And let's get started. So during this presentation, we'll talk a little bit about Albarrie, a little bit about the history, and obviously the fabrics and products and services that are specific to Albarrie, how Baghouse filtration works, selecting the right filter media for your application, types of filter fabrics out on the marketplace, and some of which are specifically manufactured by Albarrie, fabric treatments that are available in the marketplace, and how Albarrie can help you. A little bit about Albarrie. We're the leading North American manufacturer of industrial textiles, which we've been involved with for the last 40 plus years. We're vertically integrated. We manufacture all fabrics and custom-made filter bags in-house, and we're the only manufacturer in North America that manufactures both fabrics and filter bags in-house. We're dedicated to the development of advanced needle, felts, and composite materials for numerous industrial applications globally. Because we're vertically integrated, we design, manufacture, and install and service all the products that we offer. At Albarrie, we have three divisions. Albarrie Environmental Services, which focuses on industrial air filtration products and services. Albarrie Process Control services the aluminum industry and currently holds approximately 80% market share. And Albarrie Geocomposites, which focuses on oil spill containment solutions for oil-filled equipment, such as transformer substations. Albarrie Environmental Services offers a full range of customized filter bags made to your specifications, all in-house, which match your specifications as well as OEM specifications. For pulse jet baghouses, we offer parts such as cages and venturis, leak detection products including UV blacklights, pressure gauges and timer boards, as well as door and drum seals, which are manufactured in-house. For shaker and reverse air systems, we also supply caps and hooks. Our services include high efficiency cleaning, inline, in your baghouse, without removal of your filter bag cages or filter bags. We offer leak detection testing services, full baghouse inspections, whether pulse jet or otherwise, preventative maintenance programs, filter changes and full replacements, as well as advanced lab testing of used filter bags. So baghouse filtration works based on the science of contact. And when we speak of this, we're talking about air filtration, no liquid or dewatering applications. 4 items that affect your filtration operation are operating temperature, preferably the continuous operating temperature and surge temperatures that you may have in your system, and duration, if applicable, gas stream chemistry, baghouse filtration velocity or air to cloth ratio, and particle size distribution. Now we're going to show you a short video brought to you by one of our major suppliers and partners, Evonik. Of course, that video was a bit biased since it was provided by Ivonic, and it was more important for us to show you how the inside of a baghouse looks, how the bag pulses, and when speaking of construction of fabric, it's common no matter what fabric we have, so it gives you a little bit of insight into the construction of a fabric from the clean side to the dirty side. So you may or may not know that the dust cake is actually what does the filtering in a baghouse on a filter bag. Generally speaking, we recommend 1/8 of an inch to 3/16 of an inch dust cake, and that is of course application dependent, depending on your particle size, air to cloth ratio, and so forth. The fabric is the key to the dust cake formation. The more surface area that you have on the fabric, such as with a P84 fabric, the better that the fabric will provide you with surface filtration characteristics, providing you with extended life, better airflow, and reduced pressure differential. If you have too much dust cake, it could result in reduced airflow through the filter bags. With too little dust cake, you could have blinding and or emissions occurring. So again, the optimal pressure differential is application dependent. A differential pressure is the difference in pressure between the dirty air side and the clean air side, in other words, across the filter bags. Airflow and resistance determines the differential pressure. We recommend on-demand cleaning with the pressure switch versus timed cleaning for optimal performance and optimal bag life. When your differential pressure is low, again, this needs to be qualified based on your particular application and conditions. Generally speaking, a low pressure is 1 to 2 inches of water column, and sudden drops may arrive because of possible filter leak or rupture has occurred in the filter bags, tearing, mechanical degradation, and so forth. In addition to that, plug ducting may be also a reason for a low pressure differential to be measured at the baghouse. High pressure, generally speaking, again, application dependent, is above 6 inches of water column. When you have a sudden increase, it could be an indicator that the cleaning system has stopped functioning. A material discharge device such as a rotary airlock or screw conveyor is no longer operating correctly, or dust particles are embedded in the filter's fibers and unable to be removed by the existing cleaning system. Gradual increase could be caused by too much dust cake on your filter bag. So signs of some baghouse problems, as you see on the right, would be visible emissions. When you see a dark cloud above your stack, you know that you've got issues. Lack of airflow, which would be obviously shown by your measuring device, whether magnehelic, photohelic gauge, or some other device. And another problem is heat source not working or performing properly. Generally speaking, in the industry, we talk about high temperature fabrics or processes versus low temperature fabrics or processes. In general, we consider a high temperature application to be one that will be operating at more than 275 degrees Fahrenheit or 135 degrees Celsius. And low temperature application would be operating at less than 275 degrees Fahrenheit or 135 degrees Celsius. And generally speaking, this is a measurement that would be taken either in the baghouse or in the inlet duct directly in front of the baghouse. Now, at this point in the presentation, do we have any questions from the audience?
If there's any questions, please be sure to type them in and we'll take them really quickly here. You can type them in and I'll be able to see your question. Oh, looks like we have one question here. What pressure drop is considered too high?
John, would you care to take this question?
Saying I'm unmuted.
You're unmuted, John. I've got you.
Good.
Yeah, we can hear you. Perfect.
Generally, when a baghouse is manufactured, 6 to 7 inches of static across the filters themselves,
John, we cannot hear you at all. Can you speak up?
Yeah. Generally, when a baghouse manufacturer builds in the static of the fan, he considers 6 to 7 inches across the filters themselves. Now, at that point, when we reach the 6 to 7 inches, the fan will drop off its curve and you will get decreased airflow at that point. So you need to keep the bag cleaner, let's call it, under 6 to 7 inches. Hope that answers your question.
All right, awesome. Thank you so much. Hopefully everybody could hear that.
Thank you very much, John, and we'll carry on with the presentation. So now we'll talk about selecting the right filter fabric or media in 5 easy steps. So one of the main criteria for determining the proper fabric for your application is pass bag performance. In other words, what kind of life are you experiencing? Emissions, high differential pressures, mechanical degradation of the fabric, and so forth. Operating temperature is key in selecting the proper fabric for your application, especially based on the pass bag performance. Once we know a temperature based on a previous slide when we mentioned high temperature, what was considered to be high temperature versus low temperature, it eliminates a number of fabrics depending on that temperature. So these first 2 items are very, very important in selecting the right filter media for your application. Baghouse filtration velocity or air-to-cloth ratio is also very important. Do we need a surface filtration fabric based on a high filtration velocity, or can we get away with a lower cost depth filtration fabric based on a lower air-to-cloth ratio or filtration velocity? Gas stream chemistry, something that we will discuss a little bit later, but sometimes if you don't know it, it's very difficult to predict, but there are ways to do so. And particle size distribution, again, is a standard fabric, conventional fabric required, or do we need to go to a blended fabric or a dual density, micro denier, or would we need to go to a surface filtration fabric? So based on your past performance, this really #1 point is a must-have. We need to know what you're currently using. Are you using polyester, PPS, acrylic? Which type of fabric are you using? And what issues are you having? Are your bags emitting? Are they blinding? Again, mechanical degradation, high differential pressures, or a combination of all of the above. Moisture levels are very important to know within your gas stream and within the baghouse. Again, that could be a decision maker for what type of treatment you have, if any, on your filter bag. Knowing what the chemical attacks have been in your filter bag, and you may not know this precisely, but if you are in doubt, you can always send one of your used filter bags to Albarrie to provide a full analysis. Sparks or embers is probably the easiest thing to determine. It's pretty obvious when you see a filter bag or a flame coming out of your baghouse to know that there are sparks or embers that have come into contact with your filter bags. Another thing that we would need to know is where your priority is in terms of energy consumption. Is it important? Are you able to measure it? Do you need to improve it? That can assist in the choice of a proper filter media as well. And also, are you looking for a band-aid approach where you just want to fix your problem temporarily? Or is this a long-term solution that you're looking for, in which case, in most cases, you're going to go to a premium product that's going to give you much better performance initially at a higher cost. Determining your continuous operating temperature. Your continuous operating temperature as well as your excursion, and if you have excursions, for what length of time, is very important in determining which fabric you would use. If you don't have a probe in your current system, we recommend that a probe, if you have continual problems with the temperature in your fabrics, we recommend that a probe be installed just prior to the baghouse in your inlet duct. Filtration velocity is also a very important must-have parameter, also referred to as air-to-cloth ratio. The higher the velocity, the more difficult it is for your filter bag to perform within your baghouse. And OEMs typically spec this out, but over the course of time, Someone may add a new fan, may add extra pickup points, which causes your air to cloth ratio to go up. And as a result of that, makes it much more difficult to filter out what's coming from your gas stream. If you're not sure of your airflow, Albarrie can help you out by simply providing us with your airflow, the airflow or ACFM of your system, and the total cloth area in your baghouse. And we can do those calculations provided you can give us that information. Gas stream chemistry is basically a byproduct of your burn and can be difficult to obtain. Moisture percentage is very important to know. Things like fluorine, sulfur, and oxygen, just to name a couple, we would really need, especially in high temperature applications, we would really need to know the concentration of each of these in your gas stream. Sometimes a third-party analysis, if you don't have all that detailed information, is required. Particle size distribution is another one that's very difficult to evaluate, or you may not know that within your current network within your company. And typically it's determined by third-party analysis if you don't have it available. And we can, if you're interested in something like that, basically all we would need is a coffee cup of dust, and we actually would send that to a third party to have that analyzed.
All right, guys, we have another quick poll here. I'm just gonna ask this question is, what is the typical issues that you have in your dust collector or in your baghouse? Love to get a pulse on that from the audience here today. So if you can just take a second to answer the poll, that would be fantastic. Awesome. It looks like we have quite a bit of people who are running pretty inefficiently. We also have some combustion fire issues in the audience. Oh, and some abrasion. Yeah, it looks like a lot of a little bit of everything here. Also, oh, we're getting some blinding now, a little bit of that. All right. Perfect. Thank you, guys. So yeah, there's quite a few issues that are out there. So I'm just gonna close that off, and can everybody see the screen again? All right, perfect. So we're also going to have another opportunity to answer some questions at this point. Does anybody have any questions? Just type them in very quickly, and we'll get to those questions. It looks like we have one here. It says, I have a baghouse that is off of a calcinating operation, and I'm only getting 6 months of life. What would you recommend?
John, would you care to take a crack at that?
Yes, this is a question that's going to create questions, but we would need to know what you're presently using for your fabric. Why do you say it lasts 6 months? So what's your failure mode? Is it blinding? Is it creating holes? Et cetera, et cetera. If you could give us the information on a separate email, I think we have your contact info, and we could certainly get back to you. This is something we do every day, and we can certainly help.
Okay,
All right.
thank you, John.
Thank you. Yeah, thank you. All right, so Dwayne, you're going to take back over on this presentation here.
Okay.
Awesome. Thank you.
In this section of the presentation, we'll talk about types of filter fabrics, woven versus non-woven, that are in the marketplace today. And Albarrie also go into Albarrie specialty fabrics. Some of the wovens that are in the marketplace today that you'll find predominantly in shaker and reverse air systems would be fiberglass, polyester, PTFE, and aramid. Advantage basically for any of these fabrics would be that they are good and more suited to shaker and reverse air systems. Some of the disadvantages would be that they're inefficient relative to their non-woven counterparts, with a potential rapid rise in pressure drop resulting. High emissions, large pores don't always capture the particulate, not as well as non-woven needle felts, and typically you would get a shorter life out of these fabrics. And typically, wovens are used in applications with air-to-cloth ratios or filtration velocities less than 2 to 1. Some of the choices for non-woven needle felts would be PTFE, PPS, polypropylene, polyester, polyox, P84 polyimide, meta-aramid, and acrylic. The advantages would be better for filtering finer dust due to the three-dimensional structure, high operating air permeability, improved particulate capture, improved airflow, longer service life, and long-term overall cost savings. As a result of most of these, you will see much better performance and reduced differential pressures across your system. In addition to that, the non-woven needle felts provide better abrasion resistance than their woven counterparts. One disadvantage of a non-woven needle felt is that it is typically just used in pulse jet applications and is not really designed for and will not perform well in reverse air or shaker systems. When we speak about heat or baghouse temperature, generally in the industry, we consider two classifications. One is low heat and one is high heat. Low heat felts and low heat baghouse temperatures we would consider to be those that come in under 275 degrees Fahrenheit or 135 degrees Celsius. And those fabrics would be polypropylene, polyester, and 100% acrylic. In the high temperature category, we would be looking at PTFE, PPS, polyox, P84 polyimide, fiberglass, and meta-aramid. And keep in mind that this is just referring to conventional or standard fabrics and does not address the meteor fabrics that Albarrie has, nor the tandem fabrics, which we'll discuss later in the presentation. So here's kind of a table, just good for use as a reference guide. Again, these particular operating temperatures are continuous, and this information is provided by the fiber manufacturers. And these particular conditions would be measured under hot, or rather dry, benign conditions, if you can call it that. So it may differ a little bit for your baghouse application, but we can certainly consult with you on that. But basically, here's the kind of a reference guide for polypropylene, polyester, and acrylic, which are part of the low temperature range of fabrics. Same thing with this one. Again, very, very simple conditions that these particular fabrics are measured under to give you the continuous operating temperature. Now we'll go into the presentation to discuss specific to Albarrie, our tandem fabrics, which are P84-based fabrics, and our meteor fabrics, which are basalt-based fabrics. And the basalt-based fabrics are unique to Albarrie in that we are the only manufacturer globally that offers this into the marketplace. Albarrie's tandem fabric consists of a multilobular P84 surface layer, and that surface layer is needle punched to acrylic, polyester, PPS, and meta-aramid. At a fraction of the cost, we can offer this to the marketplace compared to 100% P84. When we developed this fabric many years ago, there were a number of applications that were difficult to filter in, and as a result of that, a very costly P84 polyimide bag was purchased. We decided that the marketplace needed to see a more cost-effective fabric, and as a result of that, we created our tandem filter media. So there you'll see in the top photo, the 100% P84 fiber, which is like an alphabet soup or multilobular shape. And in the bottom photo is your typical standard filtration fiber, which would be polyester, meta-aramid, PPS. And as a result of the increased surface area that you can see on each individual fiber, when you needle that into a non-woven fabric, it results in an increase in surface area relative to your conservative and standard fabrics. Basically, there's about a 6 to 8 times increase in surface area on the fabric, which allows you for better filtration performance, better bag life, reduced compressed air consumption, and reduced degradation on the fabric because you pulse the fabric less. With the lower fiber and the conventional fibers, it's based on, and I think we saw that back in the Evonik video, the concept of filtration is depth filtration, and with the P84 fiber, it's based off of surface filtration capabilities. So some features of our tandem fabrics. Due to the presence of P84, it's non-flammable. They are generally non-flammable, very stable in hydrolysis conditions, and very chemically stable. And again, this is a result of having the premium P84 product needle punch to a standard conventional fiber. There you see a cross-section photo. The top photo more to the right is of tandem, and you can see that the dust does not penetrate into the P84 layer, staying predominantly on the surface. And the bottom left photo is a conventional fabric, such as polyester PPS. And as you can see, the dust penetrates the fibers. This will reduce the life, increase pressure differential, increase cleaning frequency, and potential pressure PSI in your baghouse. And overall cost savings will be the result from using the tandem fabric versus your conventional fabrics. Now a little bit about the acrylic tandem fabric. It has very good chemical resistance to acids, weak alkalis, and organic solvents, very good hydrolysis resistance, and increased abrasion resistance and alkali resistance compared to 100% standard acrylic. This is used in many applications out in the marketplace currently, and one of those highlight applications is in the mineral processing industry. And basically this fabric was put in there many, many years ago to address efficiency and chemical resistance issues. The next fabric we'll discuss is our P84 or our tandem polyester fabric, which provides good resistance to oxidation, high tenacity and tensile strength, highly cost effective relative to, of course, 100% P84, and it's suited for lower humidity processes. This has been used over the last 25, 30 years in many different applications. And one of the best ones is in a mineral processing. I won't get into the specifics of the actual application within the mining industry, but essentially this particular product was chosen over 100% polyester due to its increase in efficiency. Here you'll see a little bit of a study that was done by a third-party analysis company, and it involves standard boiler dust. We're measuring here the filtration efficiency for submicron particulate with filtration velocity of 2.13 meters per minute or 7 feet per minute, and a solids concentration of 44 grams per cubic meter or 19.23 grains per cubic foot. So the top line you will see pretty close, it looks like it's pretty close to 100% efficiency. However, if you expanded that out, it's actually 99.999%. compared to the polyester, which stays and stabilizes in the area of 98.75% over the course of the 24-hour test. Now the PPS tandem version that we have, just as PPS, which we would consider to be the weak link of this fabric, the whole fabric itself involves or provides excellent chemical resistance to both mineral and organic acids and alkalis, suited for very high humidity and chemical attack processes, excellent resistance to hydrolysis, and good flame retardancy. Again, it's in the marketplace in many different applications. One of the highlight applications is coal-fired boiler, and this particular product is used for its efficiency that was required by the customer and also its chemical resistance. Here's another bit of a success story case history in a copper smelting plant, measuring pressure drop, comparing 100% PPS to Albarrie's PPS tandem. And there you'll see the pressure drop is approximately 80% more for the 100% PPS. And you'll see each time the pulses happen, you get a quick rise and then a quick fall, but then it rises up to a high pressure drop after a very short period of time. Our meta-aramid tandem product provides heat and flame resistance, will not melt, drip, or support combustion in the air, increased temperature surge protection as a result of the P84 presence, increased alkali resistance compared to standard meta-aramid, again, due to the P84 component, and outstanding resistance to a broad range of chemicals. Probably the best application we have for this, again, is in the mineral processing industry, and this particular product offers better heat resistance and better efficiency than the product that it replaced, which was 100% meta-aramid. Now we'll talk a little bit about Albarrie's Meteor product, and I think I mentioned it earlier that this product is only manufactured by Albarrie globally. It's a very robust spark-resistant fabric that is comprised of a heavy-duty basalt reinforcement that is needled to 3 different synthetic fibers that would be selected for your application based on the process conditions. There you see a photo of the 3 versions that we have currently available: PPS on basalt, P84 on basalt for higher temperatures, and for extreme temperatures, polyox on basalt. In some cases, just to talk a little bit about these fabrics, the PPS basalt has been used successfully in the calcining operation, where they were getting short life, less than a year, and now the customer end user is getting approximately 3 years life using this particular media. The polyox has been used in a cement kiln application, and I think we have a slide that explains a little bit more of that in a little bit, in a few minutes. And the P84 basalt has been used successfully in a steel mill in their EAF process, getting 5+ years life, when previously they were only able to get 30 months or 30 days actually out of many different fabrics with different treatments, different high temperatures and so forth. And that particular baghouse has 7,200 bags, and it's performed very well over the last 10 to 15 years. This is a test to show a little bit. It's a little bit gimmicky, but we're showing a red hot ball that was heated to 1200 degrees. And you'll see on the left-hand side that it penetrated the 100% PPS fabric within about 3 seconds. And on the right-hand side, it'll be a while until you see the end result. But over the course of 1 minute, you will see that the glowing ball reduces in color, reduces its heat impact, and the fabric does not get penetrated. The PPS melts away, but the basalt is still intact. So if you had this severe condition in your baghouse, this would be the fabric of choice, because you can still continue to use the fabric. It will still filter efficiently despite the impact that it has had, or the impact that this spark has had on the filter bag. And I must speak really fast because that was a real long minute. There we go. So as you can see, it's melted away the PPS fibers, but the basalt is still intact. This is the case study or success story that I was mentioning previously, where the polyox basalt was used. It's in the cement industry, locations Western USA, and the previous fabric was EPTFE laminated fiberglass. The problem that they were having was bag failure due to heat and wear to the membrane, maximum of 24 months life. And they had to deal with frequent spot changes, some as soon as 1 month into service. The solution was Albarrie's polyox Meteor fabric. The oldest compartment of bags is 8 years old, and there has been no noticeable bag failures during this time. The system itself is 242,000 ACFM during operation. During mill operation, the differential pressure is 3.5 inches. Average temperature ranges from 400 degrees Fahrenheit or 204 degrees Celsius up to 550 degrees Fahrenheit, 288 degrees Celsius. The consistent temperature surge through the week is 270 degrees or 440 degrees Fahrenheit. This is a 24-hour, 7-day-a-week operation, and the Baghouse holds 3,200 bags. Are there any questions from the audience?
All right, guys, any questions here? I don't see any. It looks like we don't have any questions this time. All right, I'm just gonna move along.
Now this part of the presentation goes into discussing fabric finishes and treatments, types of finishes, and lamination versus treatments. What is a finish, you ask? The manufacturer does something to the fabric to give it a different function. Typically, a finish is applied to a fabric to promote better dust cake release. 3 of the finishes that Albarrie offers are plain finish, which is the fabric is subjected to heat setting and calendaring only. This particular finish on a filter bag would be used in a application that has no moisture with dry, fine dust. A singed fabric is probably the most common in the marketplace for your conventional fabrics, and the singeing process exposes fabric to a flame to melt the exposed fibers off the surface. And a glazed finish is one that was commonly known historically and may even be termed these days as an eggshell finish. And it puts the felt through 2 heated rollers that melt back the loose surface fibers to create a smooth finish. And this typically is used in moisture-rich applications, of course, generally on polyester. So you're in that temperature range under 275 degrees Fahrenheit. So lamination versus treatment. Lamination typically is a membrane, EPTFE membrane laminated to a fabric, which is thermal bonded, or through the thermal bonding process, sorry. And a treatment generally immerses the fabric into a synthetic resin bath. So every particular fiber on that fabric is coated with whichever chemical you're using. Chemicals or treatments are used for severe chemical environments. The selections depend on your application process, and if you're having an issue with dust cake release, we would be glad to help you out with that. The history and performance of your current bags can be a determination of which type of treatment you need, if in fact you need any. And of course, dust cake release is the ultimate benefit and objective of applying a treatment to a fabric. So lamination is pretty simple. It's EPTFE thermal bonded to various substrates such as polyester, your conventional fibers basically, polyester, whether it's needle felt or woven, aramids, acrylic, PPS, depending on your application. Treatments that are offered are hydrophobic or water repellent, oleophobic or oil repellent, and flame retardant, which is not fireproof, but just retards flames. And each of these treatments, as well as the lamination of fabrics, is also done in-house here at Albarrie. Do we have any questions?
Yeah, we have a question here. Somebody wants to know if we offer products with an EPTFE membrane. Dwayne?
Yes, absolutely. Albarrie, for the last 10 or so years, when we saw that in the marketplace, there was a need for this. We had sourced initially, but we installed a laminator, so we do all of the EPTFE membrane lamination on standard fabrics in-house.
Perfect. And I think we're going to be talking about how Albarrie can help in our next section as well.
Absolutely. Hey, how Albarrie can help. Partnership. We believe in partnerships with all of our customers and actually suppliers of fiber. We focus on getting the right fit for you for your filter bag on your pulse jet cage. We look at filter bag longevity and try to provide you with the best and longest filter bag life possible. We have an extensive testing program, and then we'll discuss a little bit about how we're different. So with 40 plus years of experience, Albarrie works with you to determine the best fabric for your application based on your past experience, based on the current performance of your filter bags, based on problems you're having, and also based on your operating procedures in terms of pulsing pressure, pulsing frequency, that type of thing. Albarrie will help you lower your operational costs, save energy, and meet your environmental compliance through a complete analysis of your baghouse and system. Our in-house experts can troubleshoot your baghouse, and often we can do this on a rush within 24 hours notice. So when bags don't fit, there are problems. As you can see on the right-hand side, that gentleman dressed in white is, and he's obviously in a very clean environment, is you can see that the pinch of this particular filter bag on that cage is quite large because he's actually fitting his thumb down between the inside of the snap band and the cage. So improper fit generally means problems. If your pinch is too loose or your bag is too loose on your cage, that could cause premature wear and vertical failure on the vertical wires of your cage. If the pinch is too tight, you could have problems with cleanability and your bags won't clean down properly. Generally speaking, the pinch that we recommend is between 1/4 of an inch, and this is for standard felts, 1/4 of an inch to 3/8 of an inch. So the bag body diameter will be 1/4 of an inch to 3/8 of an inch larger than the OD of your filter bag cage. So prior to manufacturing a complete order, we would send a test bag to ensure fit on your particular bag cage. In addition to that, if your cages are in poor shape, we would also make recommendations and could offer you brand new cages to ensure that you have the exact proper fit. So how we help with longevity or extending the life of your filter bags. We're experts in manufacturing, again, for the last 40 plus years, of fabrics that are suited to your particular application. We ensure that you get the right fabric, and we make sure that the baghouse system is running optimally. Again, your pressure differential, make sure it's operating or at a proper level. Your compressed air consumption, we will look at to make sure that you're not overpulsing the bags. And we'll make sure that each of the valves and solenoids are working properly and as well as they can within your existing system. So our baghouse testing program, after consultation and obtaining all of your application details and fabric selection, we will initially test bags for suitability in a compartment or the full baghouse. So once we've come to an agreement that fabric B is correct for your application and we want to go forward with a full test, it's recommended rather than just putting a few bags in mixed in with your current filter media, we would recommend putting a full compartment or a full baghouse of test bags in if the baghouse is not compartmentalized. So we have over 40 years of experience manufacturing fabric and of industrial air filtration expertise, and that basically is from start to finish. We bring the fiber in, we manufacture it into a fabric, we put whatever finish or treatment is required, we convert that to finished filter bags suited to your particular application and as per our recommendations, and we'll get you going in the right direction. Our complete quality control, because we control the manufacturing from start to finish, and in addition to our service processes, which we've been basically supplying those services for the last 35 plus years. We do have a good response time, rush as needed. As I mentioned earlier, if you do have a need, quite often we can get someone on site within 24 hours. Again, depending on location, depending on severity of the issue, and depending on the crew members that we need. But at least we can have a representative in front of you within 24 hours. Our full baghouse services include high efficiency cleaning, which is done in place in your baghouse without cage or bag removal to alleviate differential pressure problems. Full troubleshooting of systems, whether pulse jet, shaker, or reverse air. and installations of all types of filter bags. We do have a guarantee where we make every filter bag from the highest quality, technically innovative filtration fabrics most suited to your application. Do we have any questions from the audience?
All right, guys, any questions? Be sure to type them in, send them over. We're just coming to the end of our presentation here. This will be our last opportunity to answer any questions. But of course, if you don't have one right now, but you have one later, you're more than welcome to throw us an email. We will be sending out the copy of this presentation and a copy of the whole webinar later this afternoon. And also, if you can just stick around once we end this presentation, we will be asking everybody, it's like seriously a 5-question quick survey, help us improve the information. Dwayne, did you want to add anything else?
Yeah, I just wanted to thank everybody. I want to thank you for your assistance with this presentation, Julie, and I want to thank everybody for participating. And I hope that the information was informative. And if you have any other questions or need some help, we'd be pleased to get back to you.
Yes,
thank you very much,
absolutely.
everyone.
Yep, thank you so much, Dwayne. Thank you, John, for being on hand to answer any questions for us that are technical. Again, if you have any questions, we're happy to answer them. You can send us a quick email, hop on our website, and as soon as I finish this presentation and end this webinar, you will get the survey. If you can just stick around and take that, that would be great. Thank you, guys.
Thank you, everyone.